Hey guys! So for your first step on this geometry real math journey that you are about to take, we have to learn a new way of thinking about stuff, right? Most of the time in math, you guys are like super focused on the final answer, okay? But more so, you kind of go from the beginning to the end, right? So you have something and you know that you can do the same stuff to both sides. And so you do these like linear steps one after the other, but they go in a very particular order, right? Step one comes before step two. Step two comes before step three. In geometry, sometimes it's a bit different than that. A lot of times it is. So I want to teach you kind of the reverse of that, right? And I'm going to give you an example. Let's say that you come home one day and you have an empty plate of cookies. All right, you had cookies, now you got no cookies. And, well, obviously you're super grumpy because somebody ate your cookies, but you're going to try to prove that Fred ate your cookies, right? He's like basically a criminal. So here's Fred over here. You think that he ate your cookies. And now you have to prove it though. So how are you going to prove it? If you've ever watched any kind of a crime show, you got to prove that the person who committed the crime was actually there at the location of the crime. So maybe you want to prove that he was at your house. That's a good first step. Okay, so then we need to figure out a way to prove that he was at your house. How can we do that? You can, if you've watched a crime show, you can find little hairs, or maybe you can find some footprints. And we say, okay, these footprints, they match Fred's footprints, so I'm pretty sure Fred was at my house. All right, cool. But now we got to prove that he actually ate the cookies. So maybe we go searching around in his clothes and we're going to check his pockets. All right, we're going to look inside of his pockets. And it turns out that we find crumbs in his pockets. Incriminating evidence. He definitely ate your cookies. All right, this is a simplified example, but let's walk through it. What do we then do with this? Here's kind of what geometry is going to look like. Okay, this is, right, a kind of a real life but also simplified example, but this is the idea. You start out with your empty plate of cookies. We use this reason given because there's just information in the problem that will be given to you, and there's no like reason why it's true other than that you were just told that it was true, okay? So in this case, you can see that it's true, but we're going to use that reason given to start out. Obviously, if we don't have that there, then there's nothing to go off of, right? If you just like don't tell anybody that you have an empty plate of cookies, then people are going to be like, what are you talking about? You try to like prove that Fred stole your cookies, but if you don't have a starting place, it doesn't really make sense. So we're always going to want to include that, right? Then we want to, at the bottom here, prove that Fred ate my cookies. I'm trying to prove that Fred ate my cookies. All right, cool. So this is where we start. First step, I'm going to try to prove that Fred was at my house. All right. How am I going to do that? I need some kind of a reason. And that reason was his fresh footprints are outside of my house, right? So he was definitely at my house today. These footprints are fresh. They're brand new. I know he was at my house, and this is my reason. Next step, what are we going to prove? Fred had cookies today. I know he ate cookies today. But what's my reason? He has fresh cookie crumbs in his pocket. All right, so I know he ate cookies today. And then, now we're going to use this stuff to prove Fred ate my cookies. Our reason, he was in my house, plus he ate some cookies equals he ate my cookies. All right, again, this is kind of goofy. Obviously, this final reason isn't entirely foolproof. Maybe you would need a lot more steps and a lot more pieces of evidence. If you wanted to get real scientific, you could compare your cookie crumbs to the cookie crumbs in his pocket and see if they had the same amounts of sugar and flour, and you know that it was the exact same recipe, and, whatever, right? So some geometry proofs are going to be more intense, less intense, easier, harder. But the fundamental idea is that we started with this thing we wanted to prove, and we figured out kind of from going backwards what we needed in order to prove it, right? So we said, okay, this is what I want to prove. I want to prove Fred ate my cookies. In order to do that, I kind of need to know that he was at my house. And in order to prove that he was at my house, I need some kind of a reason. So that my reason is going to be that we've got these footprints, okay? And then I also need to prove that he actually ate cookies. And so then I'm going to check his pockets and I find some evidence there too. So it's kind of this backwards thinking thing, right? If I want to prove this, what do I need to know? If I want to prove that, what do I need to know? If I want to prove this thing, and you keep going backwards until you get to what you already know, which is, I have an empty plate of cookies. And once you have that, then you've got a full and solid proof, and you just need to write it out. Statement, reason, final proof with the reason, right? So, this is your basic idea. It is a new way of thinking. It's not a way that you've been used to thinking. A lot of algebra is very forward. Some of geometry is going to be a little bit what feels like maybe backwards. But I know you can do it. Stay awesome, you guys, and let's practice.